Hello everyone. Today we are here for the final presentation and defense of Sultan Alshamrani. And so Sultan has been working on studying internet users' interactions and behaviors, particularly as they pertain to social media, using natural language processing techniques and geared more towards safety. And so since the last time we met here for his proposal, he has taken the feedback of the committee members on top of what he proposed, and he implemented those items, and he will present them along with the whole narrative of his dissertation. And so without any further ado, you will have 40 minutes of time uninterrupted. If you, any of the folks on the call today have any questions, please use the chat box, put your questions. It will be also helpful if you put the number of the slide to which the question pertains, so that we can navigate through them. And then once the 40 minutes is done, then we will go over an open floor questions, 10 minutes or so, then a few minutes more of closed discussion, where everybody else other than the candidate and the committee members will be excused. Then the candidate will be put into a waiting room, and then we'll come back to get the feedback, the final decision of the committee members. And so time counting, you start on 2:02, so you have 40 minutes. Please go ahead.
Okay, thank you, Prof. Hello, everyone. Thank you for attending my dissertation defense. Special thanks and gratitude to my committee members, Dr. David Mahisen, Dr. Yanji Fu, Dr. Wei Zhang, and Dr. Sung Choi. I am Sultan Alshamrani, and today I'll be presenting my dissertation titled Studying User Interaction and Behavior in Social Media Using Natural Language Processing. A brief introduction about myself. I am a PhD candidate at University of Central Florida, advised by Professor David Mohaisin. I completed my bachelor's degree from University of Tabuk at Saudi Arabia, and my master's degree from Loyola University of Chicago. My research focused on the integration of advances in deep learning and natural language processing for understanding, detecting, measuring the user interaction, and safety through large amount of data collected from different social media platforms. After my PhD, I will be joining Saudi Electronic University as a tenure track assistant professor. And here is the outline of my presentation. I will start by introduction and motivation to highlight the general scope of social media analysis with respect to the interaction and what constitutes my research objective. And then I will go over a unifying background of the theme of my work, including data representation, classification, topic modeling, and model explainability. And then I will introduce 3 studies that I conducted on the interaction, engagement, safety of user online. Then I will conclude. Let's start by introduction and motivation. As we know that the usage of different social media platforms are rising in popularity, and according to Statista, as of 2019-2020, the average daily social media usage of the internet amounted to 140 minutes per day. And this growth is in social media is vital for scholars and researchers to explore this new form of communication. And one of the main contributors to the popularity and the rise of such platforms is the user interaction and engagement. However, not all engagement are safe and constructive. Some users may misuse such features to promote hate, profanity, especially directed at vulnerable population. And also there is the poor sentiment toward different objectives, reality of everyday topic. The key theme here is to study the safety of such engagement through toxic content classification, topic modeling to understand the topic discussed, and the sentiment analysis of people perception and views of different topics. And recently, the human language has been mostly analyzing human language has been mostly analyzed by natural language processing and deep learning technique, as the natural language processing is one of the most promising methods used in social media analysis to better understand the human communication on a larger scale. So we build a pipeline based on this technique for addressing several engagement issues, specifically the detection and measurement of kids' exposure to inappropriate comments posted on YouTube, studying the association between topic content covered by the mainstream media and the toxicity of the comments and the interaction of user with such toxicity, and finally studying the user interaction with sentiment and general behavior towards different topics discussed in Twitter in the light of COVID-19. To address this issue, we study in this dissertation, we built pipelines used for them to address the research objectives. First, I will show 2 examples of the pipelines that we use in most of the objectives and what it's been used for. Then I will, to make it easier for the listener, I will then go quickly over each of the concepts and tools used in this pipeline. The first pipeline is the classification pipeline that we employ, which is used for the comment toxicity classification. In this pipeline, we start by collecting data from different sources for the purpose of training and evaluating the model. Then the comment collected will be pre-processed, clean, and use several representation before feeding the representation to the model for training and fine-tuning the model, and finally we get the highest performance model to be used in our studies. And the second pipeline we employ, which is mainly used for the topic discovery, where we provide the entire data set we are interested in for the given task and prepare it to be represented in a bag of words representation, and then feed them to the topic modeling technique that will produce different topic and calculate the coherence score to ensure the quality of the produced topic. And in the next few slides, I will go over each of the concepts provided in the tool pipeline. So first of all, machine learning models cannot directly handle textual data. Therefore, they have to be transformed into numerical representation, which is called vectorization, as we can see in this figure. And there are different vectorization methods. And this work, we use bag of words for topic discovery, word topic, and GLAF for a toxicity classification, and finally, word piece for the sentiment classification task. The first representation I will go over is the bag of words, which is one of the simplest text vectorization technique. The intuition behind it is that 2 sentences are said to be similar if they contain a similar set of words. And the second representation used is word to vec, which is a word embedding based on the word context using a small neural network. And then the GLAF, the vector global vector for word representation, which is unsupervised learning algorithm for obtaining representation of a word. And finally, word piece, which is word segmentation algorithm that forms a new word of a token to match it with a representation in a pre-trained dictionary of words and their embedding. For example, if we have the word embedding and there was no encoding for that word, it will be divided into subwords and search again for the encoding until it's divided to a character level. And this is done to ensure that the proper encoding for out of vocabulary words such as misspelled words. Next, I will show the models that we use for the classification task, which is we use for the toxicity, we use a deep neural network, which is a subfield of machine learning concerned with classification algorithm. The model architecture we use is composed of 2 dense layers. Each has a size of 128 units with reload activation function, followed by dropout operation of 20% to avoid overfitting. And the last layer is a fully connected layer to a sigmoid function. So for binary classification, so a comment will be transformed into numerical representation using one of the technique I mentioned previously, and then it will be fed to the neural network, and the output will be a ratio of the likelihood of a comment belonging to a targeted class. The second model we use is the LDA for the topic discovery task, which is a type of statistical model used for discovering abstract topic that occur in collection of documents, intuitively giving that a document is about a particular topic. One would expect a particular word to appear in the document more or less frequently. By providing the LDA the number of topics in advance, it generates a set of topics represented by a set of words. Then the LDA will map all documents to topic in a way such that words in each document are mostly captured by these topic we see. Next is the language model. We use BERT for the binary directional encoder representation from transformer for the sentiment classification task, which is a language model that relies on transformer attention mechanism that learn the contextual relationship between a word in a text. And since BERT's goal is to generate language representation model, it only uses the encoder part of the transformer. And before processing starts, BERT needs the input to be changed with some extra data, such as the token embedding, positional embedding, and segment embedding. And then the final representation will be with the final representation with the added special token will be fed to 6 layers of transformer, followed by a dense layer with a sigmoid function for the targeted task. The final concept I will introduce is the model explainability using line. And the main idea of model explainability is to make the machine learning model as explainable as possible, which essentially help in testing their reliability and reason about their prediction. LIME, which is a local interpreter model agnostic explanation, which is widely used in the explainable AI domain, which provides better understanding of each prediction. And despite other explanation methods, the central idea behind LIME is that it gives the explanation, for instance, being explained by perturbing different features rather than producing explanation at the entire model level. And this is a brief and introduction of all methods and concepts used in this dissertation. And the remaining chapters, I will go over each of the issues we addressed in this dissertation. The first issue we're trying to address is the studying the kids' exposure to inappropriate comments on YouTube. As we know that recently young users are spending more time on social media, as shown by this study from YouGov, where they found out that 1 in 5 teenagers is spending 4 hours or more on social media every day, which increased the chance of young users being exposed to inappropriate comments online. And such inappropriate comments can be targeted towards different users online, irrespective of their age group, resulting on severe threat to young user behavior such as anxiety, depression, or isolation. Therefore, and in order to study such issue, we collected 4 million comments posted on children's video on YouTube and manually annotated around 6,000 comments, and utilized the state-of-the-art technique in deep learning and natural language processing to construct a symbol of classifier to detect 5 age and appropriate category for online toxicity. And we provide in-depth analysis of children's exposure to inappropriate comments. To conduct such a study, one of the most important things is to ensure finding a list of kids shows that are mostly viewed by children. So we selected the top 200 children's shows based on Ranker, and the list was originally made by Ranker, which has more than 1.2 million votes. And to provide a clear measurement of the exposure for different age group to the toxic comments, we mainly use Common Sense Media as the main source for defining the age group of the selected children's show. And for some shows that are not listed on Common Sense Media, we use Parent Guide in IMDb to get the appropriate age. As for the collection approach, we started the collection by providing the 200 shows to YouTube Video API to retrieve the top 50 videos. And then we use each video ID to obtain video statistics such as views, likes, dislikes. And finally, we use Comment API to collect all comments from the video. Here is an overview of the data collected for this study. We can see that on the left, the distribution of the comments over the years, and on the right, the number of videos collected in each year, showing the increase in the number of videos and comments in recent years. And we know that the collection was until March of 2019, which is only 3 months. Otherwise, and based on the observed trend, the number might become much higher by the end of that year. And here's overview of the dataset used for training, fine-tuning, and evaluating and the detection of the model. It consists of 2 parts. The first part is a Wikipedia dataset, which is a manually annotated dataset provided by a conversation AI team with approximately 160,000 comments from Wikipedia stock pages. The second dataset, which is a manually annotated dataset of around 6,000 comments selected from YouTube video for the purpose of fine-tuning and evaluating the model. Using both datasets, we represented them using a pre-trained word-to-vec on Google News Corpus, which has 3 million English words, each represented as a 300-dimensional vector. And the second representation is Globe, which is trained on Wikipedia 2014, and GigaWord 5, which has 4,000 English words, each represented as 50-dimensional vector. For the classifier, we train 5 deep neural network model classifier for classifying 5 unsafe categories, and the model are trained using the Wikipedia dataset and fine-tuned and evaluated using the manually annotated ground truth from YouTube. And here we can see the model performance across all categories with an overall F1 score of 74.5%. After applying the ensemble classifier on the collected comments, we show a summary of the key findings of the study, showing where some exposure of kids from a different age group to an appropriate comment. In this chart, we can see in the x-axis different age group, and in the y-axis the number of comments in each category as showing in the legend. We observe that toxic comments are highly common in children video, which exceeded 200,000 comments on video only targeting the age group 6 to 8 years old. And we can also see that insulting comment is clearly noticed in video targeting children from age 3 to 5, and around 50,000 comments, which correspond to 7% of the total comments posted on video for children 3 to 5. And for the same age group 3 to 5, we observe that they are the second most exposed group to inappropriate comment, with 8% of the comments posted on their video. Even though young children from age 3 to 5 may not be able to read, but there is a chance that kids from age 6 to 13 may also be interested on the same content. And more importantly, regardless of kids' ability to read, kids' space should always be free from toxic behavior such as hate and profanity. The second section of this dissertation, which contributed toward the safety of children online, is studying the exposure of the children to the malicious URL. As we know that some malicious user may post malicious URL on different social media platforms to get as many victims as they can. Kids can be easily targeted to such malicious behavior, since they may intentionally or accidentally access the content of the malicious URL. In this study, we used regular expression to extract URL within the comments. From the collected dataset, we extracted more than 8,000 URL. And to understand the actual content of each of the websites, we used Web Shrinker, which is a machine learning classifier for categorizing the domain of a given URL. And we can say that generally most URL shared on children video are ones for entertainment and streaming websites. And to ensure to check whether the posted URL are malicious or benign, we first check the validity. If the URL posted on children video are accessible, then we will forward it to VirusTotal to check if they're benign or malicious. And we show the distribution of the malicious URL across all video over the years. And here we show some statistic of the exposure to URLs that redirect users to websites that have inappropriate content to be accessed to by kids. On the left, we see the number of comments in each inappropriate category. and in the right, the user engagement with comments with inappropriate URL. Among inappropriate category, advertising and illegal contents are the most popular form of inappropriate URLs on children video. And as for the interaction with inappropriate URLs, comment with political URLs have the highest interaction with an average of 3 replies and 144 likes per each comment. And here we show the number of videos and comments containing malicious URL, as well as the popularity of the comment with the malicious URL. We observe that video for kids from the age 6 to 8 is the highest age group exposed to malicious URL due to the popularity of the malicious URL, as represented in the high number of likes, comments, and videos. In this table, we show the user exposure to video with each type of malicious URL. As we can see that video with malware sites embedded in the comments have an average number of viewers of more than 51 million views, and videos and more than 61 million viewers for video with phishing URLs. And intuitively higher number of viewers increase the likelihood of being exposed to such malicious URLs. So the work in the previous 2 chapters contributed to the safety of children online. For that, we collected a massive data set to study the safety of children on YouTube, studying the exposure of kids to such inappropriate and malicious comment online, showing that children are exposed to such malicious behavior, and call for increased awareness of such exposure and take the measures to ensure that children's safety from such exposure while on the internet. The third chapter of this dissertation is the user interaction with the mainstream media, in which we examine the correlation between different types of toxicity and the news topic. And nowadays, we know that YouTube has become an important source for news for many people around the world, as a recent study have shown that quarter of all US adults say that they get their news mainly from YouTube. And this huge growth has attracted news publishers to deliver their content through the video sharing platform for fast delivery of the content and to enable the social component part of the interaction with their viewers, which is enabled by the comment section of the video. As people get engaged in the discussion for different news topic, however, some user might impose hate or become toxic when discussing certain topics. Therefore, we are trying to observe and investigate the relationship between variety of news topic and different toxicity type, which can be a massive help for a news publisher as well as a comment moderator to focus on topic that would result in highest amount of toxicity. To conduct this study, we collect a data set from comments and transcript of video for news segment, and we collected around 7.3 million comments posted on news video, and the video we're collecting for this study was 14,500 news video from the 13 news popular channels speaking in English. The collected data set is distributed from early 2007 until October of 2019. We were able to extract the video caption from 10,800 video, as the remaining video do not include caption, and the comments were collected in this study were posted from around 3 million unique users. In these 2 charts, we show the top 15 channel in our study. On the left, we see the average number of comments for the top 15 channel, and on the right is the number of views for the top 15 channel. And the popularity of the channel used in this study can be seen in the average number of views, as shown in the right channels such as ABC, CNN, and RT have a considerably high number of views, with an average of more than 1 million views per video. As the number of views increase, the number of comments is more likely to increase, as showing on the left. Channels such as CNN, ABC, and Fox News have the highest average number of comments. And to study the association between specific toxic behaviors such as obscenity and the extracted topic from the video, we use topic modeling to assign topic to video based on their caption. And this is a necessary task since the YouTube categorization is generic. For example, 87% of the video published by the news channel will be, by default, will be categorized as news and politics, while when we use our topic modeling on the transcript, we come up with 15 distinct topics and distributed the 14,000 video among them. And the topic comment association requires defining and understanding of the topic raised in the video where the comment is observed, and the caption of the content or the transcript are represented using a bag of words by selecting the top 10,000 words to be the caption data representation to reduce the dimensionality of the representation. The LDA model used for extracting topic receive input and assign a set of topics for each document. We did a grid search mechanism to obtain the best configuration of the LDA model that allow for the highest coherence score possible by changing the number of topics at each iteration, as well as tuning alpha and beta parameter from 0.01 to 1 with increase of 0.3 at each step. Then we manually inspected the frequent words of the best performing LDA output and assign name and description to them. As we can see, LDA produced set of words, then we'll give the set of words name and description based on them. For example, we have this example, game, play, word. Such keywords we will manually map it to more general categorization such as sport. After extracting the topic of each video and detect the toxicity in the comment of for each of that video to study the association between the topic and the toxicity, our results show that among different topics, religion and violence crime news video have the highest rate of toxic comments, with roughly 25% of the comments were marked as toxic. And on the other hand, economy-related news show the lowest rate of the toxicity among all different categories. And when we investigate the relationship between the obscenity and different news topics, we found that also violence and crime-related news have the highest number of obscene comments, with 10% out of the total comments. And the news covering the United States foreign policy had the least number of obscene comments with only 3%. And the third toxic behavior is the identity hate. With respect to different topics, our study showed that African affair and religion-related news have the highest ratio of identity hate comment, with 20% out of the total comments posted on news related to these two topics. And up to here is something that I presented during my proposal for the work I have done already. Beyond this, and in the next few slides, I will show the result of the work conducted since then to obtain through further analysis, including training and evaluating model to detect association of threatening and insulting of different topics, and providing several metrics to measure the exposure of user to toxicity, as well as the popularity of the toxicity in the news space. And finally, we examine the model reliability in terms of bias toward different identities. So when we investigate the association of different topics with the insulting content of the news, we found that news related to United States political parties, religion, and African affairs have the highest ratio of insulting comments, with 23% of their comments were labeled as insults, while topics such as economy, education, family, events have the least amount of insulting comments. And finally, when studying the presence of the threat comments on different news topics, we observed that news related to violence, crime, and war attack show the highest number of threats among all other categories, while news related to United States political party have the least number of threat comments within their comments. To study the exposure of users to each toxic type, we define a set of metrics to estimate the prevalence of the comments by the audience. First, the video popularity represented by the number of views, likes, and comments. And second, the comments popularity defined as the likes and replies of the comments. Throughout our study, we unveiled a large number of toxic comments posted on different news topics. in this work, and despite the effort taken by comment moderators on YouTube, this seems to be almost consistent over the years, and there is no clear trend declining of the toxicity on the news videos. And to show the toxicity exposure and popularity, we present two charts representing the popularity of the toxicity comments as well as the video they are posted on. Here on the right, the figures show that the most frequent type of toxic behavior is identity hate and insult. Video with comment that with toxic comment are popular with a very high average number of views, where most of them have around 500,000 views with an average of 5,000 likes per video. Such statistics show that indicate that more users are exposed to such toxic behavior. And on the left, we can see the interaction with these toxic comments. To show the popularity becoming visible to a much larger audience and to perform such analysis, we calculated the average number of likes, replies to a comment belonging to each of the 5 toxic categories, as well as the safe comments. And comments categorized as threat or identity hate receive the high interaction with almost 1 reply on average and 10 and 7 likes respectively. In the proposal, I received some suggestion from Professor Fu to look into and examine the bias of the models and examine the root cause of the model prediction. Therefore, and here we examine whether the utilized model in this study exhibits bias toward a certain identity. We filter the toxic comments that have an identity word. Then we use explainable AI to pinpoint the exact word that contributed positively to the final output of the classifier. We perform such a step to check whether an identity word contributed positively to the toxicity detection, and using line on each toxic comment, a set of words will be generated as shown in the table, which represent the top 10 features. And in our domain is top 10 words that contributed positively to the classifier. Alongside the set of words, a set of weights indicate the amount of the impact for each corresponding word will be generated as well. Using both the words and the assigned weights, the results show that there is no clear evidence that any of the identity words we investigated have by itself a positive impact on the model decision. For example, when considering the identity word America in a safe context, the model will not assign any weight to it, considering it as a safe feature. Meanwhile, when an identity word occurs in a toxic context, the model will assign weight to both the identity word and the toxic word, and this indicates that the model is not considering some identity words as toxic unless they are related or described by a toxic word. Then it will be considered as an insult, which is a type of toxic behavior. In the previous chapter, we designed an ensemble of models to detect various types of toxicity in comment and topic modeling to discover the topic discussed in the news. And we investigated the correlation of different toxicity types as well as the topic discovered, showing that religion and violence crime related news have the highest ratio of toxic comments. Next, and in the final chapter of this dissertation is studying user engagement during COVID-19. While I presented part of this work in the proposal, which covered the first 3 months of when the pandemic was declared as a global pandemic, I redone the entire work for a larger data set that covered 14 months. With the same objective, we added more features in order to better understand and reason about people behavior. The outbreak of COVID-19 pandemic raised health and economic concern, with social distancing along other measures that are enforced to limit the spread of the virus. People's life has changed dramatically. During this period, the web and social media platform has become the main medium for communication, expression, and entertainment. Such platforms are a rich source of information, making them a valuable source for researchers to study user behavior and engagement. And among different social media platforms, Twitter is the most used platform daily for sharing thoughts and discussion, making this platform a good candidate for our study. Therefore, we use Twitter to understand the shift in the engagement and perception of users during the pandemic. In this work, we collected a large data set of 103 million tweets from 4 English-speaking countries, namely the United States, Canada, England, and Australia. And we provide an in-depth analysis of the collected tweets showing the shift of the topic discussed before and during the outbreak of COVID-19, as well as the user sentiment toward different topics. We utilize natural language technique to extract topics discussed on Twitter along with trending topics, user sentiment toward them. In this work, we use LDA as well for the topic modeling and BERT to track the behavior changing through the sentiment. Finally, we provide insight on who and what could be of interest to people during the pandemic by extracting, analyzing hashtag, mentioned account, and used emojis. Here we show an overview of the data set used for this study. On the left, we can see the distribution of tweets over different cities. And on the right, we see the distribution of tweets monthly. And the monthly number of tweets has an average of 7 million tweets, with a peak of 14 million tweets in November of 2020, as shown. And this increase is mainly contributed to the high volume of tweets related to United States 2020 election. Here we show the distribution of tweets over the generated topic using LDA. Clearly, and due to the nature of the platform, tweets related to family and social life represent around 30% of the tweets. Also, tweets that are related to thoughts and emotion have a huge volume with 6.2 million tweets. Even though tweets related to COVID-19 weren't discussed earlier than the virus was declared as a national pandemic, there was a considerable number of tweets, 1.3 million tweets related to COVID-19 during the studied period. The outcome of the topic modeling showed that tweets related to health services have peaked in March of 2020, which is the time when COVID-19 was declared as a global pandemic. The tweets related to health services show increase of almost 100% from February to March, as showing in the figure above. And as the pandemic has affected many aspects of people's life, tweets related to job and business have also increased as government and organizations started enforcing lockdown and many businesses were shutting down, as shown in this figure below. The second work of this study is to track the sentiment of user. We use different machine learning algorithm to find the best performing model. We use DNN, CNN, STM, and BERT, and BERT outperform its counterpart. Therefore, was mainly used in our study. The finding of the sentiment analysis showed that across all topics, school and education had the highest negativity rate when the outbreak started. After March, tweets were positive until the second spike, where the negativity increased again, as showing in the chart above. And the result also showed the increase in the positivity for tweets related to online shopping. In March, this may be because more people relied more on online shopping as the main alternative to regular shopping after a stay-at-home order was placed in different countries. And finally, we have also studied different aspects to better understand who might be of interest to people when the pandemic started. And here we show the top 5 mentioned accounts in each country aggregated quarterly. We observed that after the outbreak, most mentioned accounts in all countries were accounts of people representing their government, such as minister, leaders, and other officials, demonstrating that users were looking for guidance and help during such crisis. To this, I conclude my presentation with a summary of the work contributed to my dissertation. First, we studied the exposure of kids to such malicious behavior on YouTube, showing where some exposure for children to online toxicity and malicious content. Second, we investigate the correlation of toxic comments with different news topics, showing that religion and violence crime related news have the highest rate of toxicity. And finally, we study the change of the public behavior concerned during the COVID-19, provide insight into how the pandemic has impacted people's behavior toward different topics discussed on Twitter, showing that more people are more concerned about their job and health and education. And here is the list of the publications that contributed to my work, where I am the first author. And during my PhD, I also contributed to other publications, and here is the list for other publications. With that, I come to end of my presentation. Thank you for your attention. I will be happy to answer your questions.